Thank you everybody for being here. Got another great talk on content provenance technologies to fight online disinformation, sorry. Christian Paquin from Microsoft Research. This is going to be a really good one too.
All right, thank you very much. And it's a great pleasure to be back at ShmooCon. It's like, I knew it was a con of some sort. I've been here a few times, and it's a great honor to be here for the last one. And I'm with Microsoft Research. I do cryptography engineering research. I've worked on different topics. They change from year to year, post-quantum cryptography, a lot of anonymous credentials, privacy enhancing technologies. And most of the last year I've spent on the work that I'll be presenting today. And let's jump straight in. You've all seen that picture, I'm sure. And it's the infamous picture of the Pope displaying some extraordinary fashion sense here. And of course, it was revealed, not surprisingly, that was generated by an AI system. And this, might have been for fun, but more and more, and it's easy to find examples across all spheres of activities of fake content being generated to act revenge upon some people, like, for example, somebody trying to get colleagues fired from school by creating fake audio clips, and it, of course, touched the election in the US and in different countries around the world with fake calls, fake videos, and worst of all, they even, as a native Canadian, they've even created deep fake videos of a hockey coach, which is, our religion, and this is totally unacceptable. So we are kind of in a position to ask ourselves, will our lives become a daily life of, is it cake, but is it fake? How can we know what we're seeing online is real or not? Of course, this is not really a new problem because you could always have used Photoshop in the past and create fake content. But with the advent of very powerful systems of generative AI, this can be automated, this can be accelerated and made at scale. And there are technologies to detect these fakes, but it is, of course, a cat and mouse situation. The detectors will never catch up to the new system being created. So one way to recognize fake content is quite the opposite, is basically to attest cryptographically to real content. And there are a set of technologies that have been proposed, and the main one that surfaced is the C2PA, which I'll be talking about today. The C2PA here, if you look at this NASCAR car logo table here, you see there's a lot of organizations involved. It stands for the Coalition for Content Provenance and Authenticity. It was created many years ago as a merger of two different projects, one which we co-founded with some news media organizations called the Project Origin to be able to kind of create a trust framework for media content, and another initiative that was led by Adobe called the Content Authenticity Initiative. And recognizing that they were working on a similar problem with similar solution, they merged into the C2PA. And last year was a very important year in the space because most of the big technology companies joined the steering committee. So Amazon, Google, Meta, OpenAI. So that really cemented the position of the C2PA specification in the industry. So we might be starting in the upcoming months and years to see its deployment. So, okay, what is this thing and what can it do? So let me just illustrate this with an example, but before I do that, I will just give a quick overview. So C2PA defines what we call content credentials. It's essentially a digital signature you can attach or embed into a digital asset of any type. It could be images, videos, audio clips, or text-based documents, PDF, web pages, all sorts of things. And you can kind of think of a C2PA manifest like a GitHub log of transformations of an asset. So once you first create it, you can attest who did it and how it was created. And then any subsequent modifications, you can record them and append different signatures. So you can really get a nice audit trail of everything that was done authoritatively on an asset. So let me just give an example to illustrate the concept. Let's say I have a camera that supports the C2PA standard. It would have a cryptographic key in its hardware somewhere, securely stored. And then when the camera takes a picture, it records the pixel, but then it can attach a digital signature. It would take a hash of the pixels of the image, the same way you would do if you would do it on a computer. And it can also attach attestations of how this image was created, with what type of software, if there was some AI touch-ups, if there were a GPS location available that could be attached as well, and if there's a secure timestamp available that can be also recorded. So all sorts of statements and assertions you want to put in the manifest, you're able to do so, and that gets recorded and signed. So now, let's say when I go on social media and I look at an image, I don't see the raw image that came from the camera, right? It was sent, somebody would take it on the computer, would edit it. So let's say a image editor would open the picture, let's say Photoshop, it would be C2P compliant, so it would recognize the signature of the asset. It would first verify it, make sure nothing changed since the picture was taken. And then, let's say the editor would make some transformations, apply some filterings, make the image black and white here. So all these transformations would be recorded, and then there would be a new thumbnail that would be added to the manifest, and then that gets signed, and with the signature of Photoshop, of the software that edited the picture. So now when you look at that picture, you can have the history of the transformations, each of the steps cryptographically signed. So if you're trying to create fake content, you cannot just invent these series of facts without access to these private keys. And the type of cryptography that's used is the same PKI technology that's used to protect the web PKI. So it's the same type of certificates. And at the end of the day, it's just become a very difficult problem to solve, but it's a trust establishment problem, how to create the trust framework to see, okay, which devices and how can we trust the keys that we're seeing. So the C2PA itself is working on a conformance model to have manufacturers say, okay, Sony will have this part of the PKI, other Photoshop will have other ones, OpenAI and Microsoft signing on the back end with their AI systems, would have the keys on the server side, and all that will get recorded in a C2PA trust list that you have to go through conformance and audits to be able to get these keys certified. But that leaves out a lot of contributors that are not devices or software manufacturers. And the C2PA is open also to have these people come in. And one example I will give is for the news media organizations. So that was the goal of Project Origin, to create a trust list of verified news media publishers. So the goal here is not to say who can create true media or who is a trusted news entity. It's just to recognize that this is an entity we know of and that's their key. So whatever they sign, that's the entity that created it. And the best way to illustrate this concept is with a demo, and I will go straight into it. So BBC is part of this Project Origin, and they've started to sign some of their media. So if you go, for example, on one of these pages, they have a video from the Ukraine war, And they've actually signed it with C2PA, with the content credentials. So if I click it, I watch it from the BBC website itself, I kind of know that it's authentic because I'm watching their content on their platform. But let's say a user, let's call her Alice, because that's what I assume she calls herself, she took this video and posted it on her feed here. So how do I know that she took the original and didn't modify it? She could have modified a few seconds, a few frames that could change the whole story, right? And so if I look at her feed here, we can see that she just claimed to have been at a Taylor Swift concert. And she must be very lucky or have great connections because she appears to be in the front row VIP section. So good for her. And that's the video that came from the BBC website. But how do I know that it's authentic? So these two things might have been signed. So let's see here. I've installed a piece of software that we released. It's an open source content validator for C2PA. And if I reload the page now, what the browser extension will do is look at all the assets on the page and see if there is a C2PA manifest in there. And if so, it will validate the signature and see if it is a trusted one. So, well, weirdly enough, there is one for this picture, so maybe it was taken from her Sony camera that supports C2PA, but if I look at it, oh, it looks like it's a signature from OpenAI. OpenAI, by the way, they signed all their images. So, okay, looks like she was not fully honest about the origin of that picture. But, okay, what about the other one? So, this one was actually signed, an unmodified video from the BBC as linked to the verified news publisher Trustless. So right now, that's kind of an example where it requires special software to verify that. But you can imagine the situation in 5 to 10 years when this technology is baked in a lot of the trusted news, trusted news and a hardware ecosystem that can produce these signatures and can be validated by the social media themselves or the browsers so that we can really have trust signals to differentiate what's real and what's not. Okay. So let's go back here. Okay, so that's a whole set of engineering problem to deploy these types of systems and at scale on the internet across so many different devices and across so many different scenarios. And not everybody will need that, right? If you're just creating memes for Reddit, you don't need this content to be signed and you might want to remain fully anonymous. But if you're a trusted news provider or trusted manufacturer of some sort, you would like your content to be non-spoofable and non-modifiable. But even if you do so, you might have very strong privacy requirements, because if you start signing everything, you're leaving a big digital wake on the internet of your activities. And some users have very important verified anonymity requirements. I mean verified in the sense that you're not fully anonymous, you have some properties that are attested, but you don't want to be identified. For example, journalists reporting in authoritarian regimes to avoid repercussions or to protect their sources, or whistleblowers that would provide validated content. Or, for example, some Banksy-style artists that would like to authenticate their work to make sure the next one you see is from the same pseudonymous artist, but without revealing their true identity. So one interesting area of research that we're pursuing is using zero-knowledge proofs to make these attestations. So let's say, for example, to reuse the BBC example, if the camera from the journalist would have certified that, yes, this is Alice's certificate from the BBC organization that took that picture at its exact time stamp at this exact GPS location. But when they publish it, to avoid putting Alice in too much potential trouble or opening her to risks, I could redact this information and just say, this is one of our journalists, and it was taken on this day, not that exact timestamp that could be used to locate her in real life. And it was taken in this general location without pinpointing where she was, because she could be easier to track. And just because this is a very recent work, I've going to announce this. We released this just before the break. It's the Crescent Library. It's a zero-knowledge library that allows you to present conventional credentials with some privacy. So currently we support two types of credentials, mobile driver's licenses and JSON Web Tokens. And you can, in theory, attach these statements, this identity statement to C2PA manifests. And we're planning to add X509 certificates as well in this library in the coming months, and which will make a C2PA integration stronger. But in our example here, we can take, for example, an employment JSON Web Token, my Microsoft one, and I could use this to access a health clinic that I want some privacy. I don't want my employer to know I'm visiting this clinic, even though they're providing the service. So I can just prove to them that I'm a current employee because my email address, the domain, I could reveal it to the clinic, and I could use my mobile driver's license that I'm over 18 to join a social network, for example. So you can make these same type of statements, attach them to assets, videos, audio, and just say, I'm from this organization, or I live in this city, so I can participate in this contest without revealing, for example, where exactly I am. So that's a very interesting and area of research we're pursuing to help solve this disinformation problem, but also protect the privacy of all the participants that we need. So I'd like to leave times for questions. So that was the overview. Thank you, everybody, for your attention. Questions? There's one here. I can repeat the question.
Yeah, so I've been doing research on this particular product for 2 years. My problem with it is that Adobe at this point, which is actually the company behind this whole thing that you guys are actually associated with, they basically are issuing untrusted certificates. Therefore, it's been very easy to spoof. Does not authenticate the signer, so there's not actually any hashes there. Basically, it's very easy to authenticate forgeries. If you'd like, I have a list of 30 of them right here. We identified we were concerned. We reached back to you. We reached back to Adobe. We reached back to other people. This is kind of important. Specifically, the importance of this is that federal rule evidence actually have requirements from a law standpoint, and I have a whole list that's too long.
Yeah. Can I just shortcut and repeat like the essence of your question? So there's some critique you have on the stupid specification, yeah.
The things we found so far are
Yeah.
major problems. If somebody falsifies...
Okay, let me answer quickly, because in the interest of time, and we're happy to converse more at the end, but there was a certification, the first specification came out a couple of years ago. There was a new one, 2.1, that fixed a lot of the public critiques that we've seen. That was in September. I mean, this is an evolving set of specifications, and community feedback is great, and that's part of the reason we're reaching out. And the biggest problem, I think, is going to be the trust deployment, to establish the trust framework to see, okay, who's allowed to sign and who are these identities. And this work is still ongoing. The conformance task force, part of the C2PA, has not completed its program to decide, who will be able to be a trusted signer. And what's been done before, it was kind of a, friends and families, early adopters, and kind of very on a case-by-case basis. And that's all going to be replaced by a more trusted process as that gets developed. So yes, it's a big project to launch and a big set of specification to launch. And my personal vision is that we're kind of, first year of, let's imagine the HTTPS deployment. When you're the first few websites transition from HTTP to HTTPS, you kind of look weird and like, what are these and what these certificates? Migrate to the 10 years later when you're the last few ones, you look very suspicious. And now we have an established PKI that's worldwide, that is not without problems. So there's a lot of that work. And I don't think any of them are intrinsically unsolvable. I think that we've made critiques as part of the C2PA ourselves. It's not just Adobe leading that. Like there's a big group of companies, as you've seen at the beginning.
Adobe runs all three major
Yeah, okay. Well, I'm not sure who you are. I'm happy to talk more afterwards if you'd like to share that feedback with me. Yes.
Out of curiosity, let's say DEC had a document that they thought was legitimate, so they signed it before they posted it. They find out that it was not legitimate. Are you building a mechanism in where you can revoke a specific list of things we've signed without having to revoke BBC's entire certificate?
Yeah, so the question is there a revocation mechanism for the content? Not necessarily like for the identities like you have in PKI, but you've signed something and it's wrong. I mean, it's just a process. So it's basically digital signature on not just a document or an email, on any type of data. So in news media, they already have these retraction mechanisms, right? So that would be what you would do normally. So you could just say that. And a lot of the pictures, the videos that they did, it was not something that they signed. It's something that the statement that they signed is that we verified authenticity of this video, that we look like whoever the contributor that's on the field. We verified that geolocation makes sense. So it's kind of our newsroom is happy to say that we think it's authentic. So you can make any statements on any data and you just apply your signature on it. Okay, we're out of time. So I'll be just out the door there if somebody wants to continue the conversation. And thank you very much for your attention.